So let us begin with the statement of Pauli's exclusion principle, i.e. P, E, P, P. It says two electrons in a system cannot have all four quantum numbers same. Q and same. Okay. So what does it mean? If two electrons have the same principal quantum number, azimuthal quantum number, magnetic quantum number, they are bound to have different spin quantum number. And why is it so? If these three are same and the spin quantum number is also same, say plus half, then they will occupy the same space in that particular system. Okay, so how can we prove the statement of Pauli's exclusion principle? I found this particular proof from Reddit. So the key principle which we won't prove, because it is a fundamental principle and the proof is very rigorous from my knowledge, and I don't know that either, but I can help you with some links if you want. Let me know down in the comments. Okay, so the basic principle is fermion wave functions are antisymmetric under the exchange of particles. What does it mean? Assume the total wave function for a set of n fermions is psi of R1, R2, so on, Rj, so on, Ri, so on, Rj, so on, and Rn. Okay, so there are n terms and I and j are two random terms. Okay, here Ri and Rj are the position coordinates of the particles. Doesn't matter which two. Okay, so I can be 1, j can be 2, but I and j aren't equal, and it can be anything else too, but they aren't equal. If the wave function is antisymmetric under exchange of two particles, it means if we swap those particles, if we swap their positions, that is the positions of Ri and Rj, we are gonna have the wave function equals the negative of the wave function where j and I swap their positions. See, they swapped positions and it resulted in a negative wave function with respect to the first one. So what is gonna happen if both of them have the same position with a fixed spin? In this case Ri is equal to Rj. So antisymmetry gives us the wave function psi R1, psi of R1, R2, blah blah blah, Ri, blah blah blah, Ri again, blah blah blah, Rn equals negative of psi R1, psi of R1, R2, blah blah blah, Ri, blah blah blah, Ri, blah blah blah, Rn. So these two terms repeat. Now let's say this term, the whole thing equals A. and we can clearly see this term is also A. So we end up with A equals negative A, which is not possible because we cannot have 1 equals negative 1 and so on. So in that case, if we were to have A equals A, then 2A is 0 and the wave function doesn't exist here. And of course the only thing equal to negative of itself is 0, as I said. Then the wave function for Ri equals Rj must have a 0 amplitude, so the wave function dies down. It doesn't have an amplitude, so it means we are not going to have the probability of finding the electron in the defined space, because amplitude, the probability of finding something is roughly equal to the amplitude, is equal to the square of the amplitude. Also, let me illustrate another thing. Here we draw some electrons with up spin. So this is 1, 2, and this one is I, J and N. So if I is J, then they are bound to overlap, right? And that is the concept of Pauli's exclusion principle, that they can't overlap. So in this case we are gonna consider NL and ML to be same, so they cannot have the same spin. MS cannot be similar. While we were talking about position, this is completely generic and applicable to any quantum state. So in Dirac notation, it is Kate notation. The same thing happens. The Kate of Q1, Q2, blah blah blah, Qi, blah blah blah, Qj, blah blah blah, Qn is negative of the same thing, but I and J exchange their positions. Here Q is any set of labels that completely specify the wave function. For example, in a realistic example, Q1 might be a spin-up state of position 1 and Q2 might be a spin-down state of position 1. Right? So this case is completely plausible and possible, because if it is Q1 and it is Q2 and both have the same principal quantum number, azimuthal quantum number and the magnetic quantum number, the spin quantum numbers aren't same, because this one is plus half and this one is negative half. So PEP isn't violated. The same argument follows, and it can be shown that two fermions can be in the same quantum state. Sorry, no two fermions can be in the same quantum state. Same quantum state means they will have the same quantum number. All of the quantum numbers will be same. So for our classical example, NL, ML, and MS, principal, azimuthal, magnetic and spin, all the quantum numbers will be same. So I guess this helps, and I will do another video with the rigorous proof. This was just by logic. This one was logical proof, and we can do it in a more rigorous method with diagrams and so on. So if you want the video, you can let me know. I will try to do that later next month, maybe before Christmas time or around that time. So thank you, God bless, and be sure to like, share and subscribe. Thank you, ciao.